In this video, I'll discuss ventilation and infiltration. I have a simple model here with 5 spaces. Rendering by space type, we can see that we've got a living space, a kitchen, a bathroom, a master bedroom, and another bedroom. So if I go to the Space Types tab, on the first page, on the first tab, we see Design Specification Outdoor Air and Space Infiltration Design Flow Rates. These are where the objects for the ventilation and infiltration will go. These objects will define the amount of outside air coming into the space, either uncontrolled through infiltration or intentional via ventilation. I've put a model on a box with some typical ventilation objects for ASHRAE 62. ASHRAE 62 is the standard that governs single-family residential ventilation, and the objects have the required level of infiltration included. If you go to File, Load Library, and navigate to that file, you'll find it under, it catches up, Distributed, Reference, Datasets DW, and it's labeled ventilation objects.osm. Once that library is loaded, you can click on the library tab on the right, Design Specification Outdoor Air, and scroll down to the bottom of the list. This will still show you the files in the default library unless you change your default. And then when you get down to the bottom, it'll show you the various objects labeled ASHRAE 62 and then bathroom, bedroom, and so on. So I'm just going to simply drag one of these over here. If this wasn't already set up to be the one that I wanted, I could come in, I could change the name and change the values and so forth. If I then wanted to apply that to other spaces, I would select the spaces that I want to apply it to, select the name of the object, and then apply to selected. Now, that's not actually the value I want, so I'm going to go through and get rid of those. Then go back to library. Again, select Design Specification Outdoor Air, and bring in my objects for the various spaces. So I'm going to drag the bathroom onto the bathroom space type. And drag the kitchen onto the kitchen space type. The living room on the living room space type. Then with the bedrooms, the standard requires 7.5 cubic feet per minute of outdoor air per bedroom, plus an additional 7.5 on top of the number of bedrooms. So I have two objects here. Oh, I clicked the wrong one. Outdoor air. Bedroom first is going to include that additional 7.5 cubic feet. I'm going to change my units to IP so we can see those values that we're used to looking at. So we have our 15 cubic feet per minute of outdoor air attributed to that bedroom. And then for the other one, we'll use bedroom other. So in the bathroom, we have 50 CFM. In the first bedroom, we have 0.3 cubic feet per minute per square foot of floor area, plus an additional 15 CFM. In the other bedroom, it's the same except 7.5 CFM. In the kitchen, we have to provide 100 cubic feet per minute for the kitchen. And then in the other living spaces, and this could apply to any other conditioned space in the house, we have 0.3 cubic feet per minute per square foot of floor area. All of these have a schedule of always on associated with them. The only one where that might change would be in the kitchen and the bathroom. They could potentially operate on a schedule that was not providing that air at all times. For infiltration, I'm going to go back to my library. It works very similarly. I'm going to find the appropriate objects. This time I'll start by grabbing one of the defaults here, drop that in to see what it looks like. Here I can change the name. I can specify the infiltration via several methods, either a flow per space, flow per area, flow per exterior area, which is what the current Passive House standard wants you to do. Actually, current Passive House uses flow per exterior wall area, I believe, or air changes per hour. Because we don't have a good way to convert from that flow per exterior wall area at the pressurized level of 50 pascals to natural air changes, we're going to use air changes per hour. The standard will actually be quite similar for a smaller building like this, so we don't need to worry about that. You would input the value for whichever method you select, and then the coefficients can stay as is. I'm going to go ahead and delete that one. Go back to my library. And I already have one here set up for a particular situation. So for this one, we found that we had 0.027 air changes per hour. The way you would determine what the appropriate air change rate would be can be found here in this post on the website. It's called Infiltration Conversion, and it's under FAQ and Tips. The basic method is that you'd take the air changes at 50 pascals, which for Passive House we'll be using 0.6 ACH50. Then you would look up, using this map, your zone, your geographic zone, and then the conditions of the building, depending on how exposed it is and how many stories it is. Find the factor here, and then divide your ACH50 value by that factor. That'll give you those natural air changes. So that's going to apply to all of the spaces because we want to find the air changes for the total conditioned floor area. So we'll take that 0.027 value in this case, or whatever it turns out to be in your case. Again, I'm going to click all the spaces that I want it to apply to, select the value, and then apply to selected. And there you have it. I have my ventilation and infiltration set up. So when I run my HVAC model, it's going to pull these outside air values from the space type to determine how much outside air to bring in for ventilation. And then the model will use these values for infiltration.